We're here at the UCI Medical Center campus where NovaTech Energy Services Group has been involved in a 2-year, 2 million square foot energy rollout, primarily focused on energy efficient lighting and lighting controls. The project has been broken into 2 phases. Phase 1, it was 4 buildings plus a parking structure. Total project value was $554,000. Blended payback of less than 2 years and a 50% rebate projection. We also received 24 cents per kWh saved, as well as additional ETAP funding for new technologies. And we also received Edison on-bill financing, so the customer on phase 1 will essentially be cash flow positive $20,000 the day they accept the project every month. The second phase is going to be 20 buildings, including the brand new hospital, building 1 and 1A, and it is going to be about 6 months for the duration of the project. It's going to include primarily lamp and ballast configurations with some new models installed in different areas. The project has been pretty complex, and there's been multiple parties involved. This includes Edison, it includes OSHPD and JACO for hospital compliancy, it involves the hospital staff as well as coordination on our part. We have weekly standing meetings to review design, to review schedule, and then we have quality assurance, quality control meetings every Friday morning as well. We do this weekly just to make sure that we're on par with what the customer wants, what their expectations are, and to make sure that we meet those expectations weekly and ultimately at the end of the project. We're here in Building 55 at the UCI Medical Center. Building 55 is a complex environment. It's a laboratory space, vivarium, and it's also a space that is used for different testing and solutions. In this specific area, we're in a stairwell. Healthcare stairwells in the state of California have to be illuminated 24/7 and 365. And what we did in this actual location is reduce the quantity of fixtures by savings by design. And we removed 2 fixtures and went to a singular bi-level radial wrap. And what I mean by bi-level radial wrap is the radial wrap is the configuration, but the bi-level means that this is sensored fixture. So when nobody is in this space, one of the lamps always goes off. The benefit of this is that stairwells typically aren't occupied. So most of the time they're picking up about 80% savings in this area. Above and beyond that, we also got them an additional $100 per fixture on an incentive from ETAP, which is narrow funded implementation. So not only are they saving 80% on the fixtures, but they're reducing their spend and their maintenance when nobody's in the stairwells, and they were actually paid by ETAP to put these fixtures in. We're here in Building 55 again in a conference room that's used for laboratory teaching and classroom environments for doctors and inpatient treatment. In this area, in this space, what we changed out were all the CAN lights, which used to be halogen lights, to 2 lamp 13 watt, which equates to 26 watt CFL lamps on sensors. We also changed the pendant lights that you see here across the center area from 3 lamp 32 watt to 25 watt low ballast factor with a step dimming solution. And that allows the teachers for the medical students to provide different levels of lighting based upon what curriculum they're teaching, what they have on the board, and or what mood needs to be set for the room for the curriculum. All the different lamps are censored on a different configuration, so when they walk in, the lights will turn on accordingly to what we've preset for that conference room or that classroom. We're here again at Building 55 at the UCI Medical Center campus. Obviously you can see this is a critical environment. It's where a significant amount of laboratory testing are done. What we did in this space is all the lamps above you, or they're showcased here, were 3 lamp 32 watt configuration. We took them to a 2 lamp 25 watt low ballast configuration, which saves about 35, almost 40%. Much more efficient lamps. They actually have about 12,000 hours more useful life. And because of the high critical nature of the environment, we used a dual technology occupancy sensor, which has 2 layers of occupancy sensing, both visual and sound, to make sure that there's never false offs when somebody's working on research and development type material. So complex environment. We were in and out of this space at nighttime before the tenants or the occupants came back in. We had to do complete dust collection and protection. We can only open 1 piece of the ceiling at a time when you're in a space like this. We're here in Building 63 of the UCI Medical Center campus. This is a typical classroom on this facility campus where they train medical students and or UCI Regent students who come in here for medical training. These classrooms had a pretty unique configuration based on the multiple levels of lighting they require for either film showing, computers, or what have you. In this center, we changed every 2 lamp 40 watt biax lamp to 2 2-foot, 25-watt low ballast factor lamps. We're saving close to 50% energy in here. We've gotten great reviews on it. What we also did in here, if you notice, I'm going to turn these lights off, is we used LEDs that are fully dimmable in the incandescent cans. They're saving about 80% in these LED dimmable cans. This is typically the light that they use in this center. So we gave them the option to not only save energy, but to continue the dimming option with the newer LED technology in the cans, which can go to 100% on the dimming capabilities. We're here again in Building 23 at UCI Medical Center, and you'll notice in this center, or in this hallway and corridor, is the use of LED lighting. LED is a very application-specific technology. It typically doesn't work well in linear applications, but in single lamp configurations where you may have had a halogen flood or a par 38 type incandescent, anything along those lines, this is where LED works sufficiently. These are censored. We reduced the wattage in these by about 60%. And in this specific application, we would recommend to do it because it works with the aesthetics of the hallway and the design that the UCI campus was going for. Typically in a corridor, we would not use them, but here it was a perfect application. We're here outside of the Building 73 parking structure at the UCI Medical Center campus. This building recently underwent a complete renovation for a lighting retrofit. If you look behind me here, the stairwells are all exposed to complete ambient light levels, and they were burning before 24/7, 365, so they were lit unnecessarily during the day. What we did is we applied the use of photocell technology, photocell control on these stairwells. We retrofitted both the stairwell fixture and the elevator landing fixture with more efficient technology, one of them being induction fixtures, which should not need service for approximately 20 years. You'll also see those along the side of the building. We worked comprehensively with the campus on these fixture solutions because maintenance is a big issue for them here. They don't have the crews or the staff available to actually get to the maintenance needs of the structure. We'll take a look inside at the rest of it in just a second. Sorry. We're here in Building 73 at the UCI Medical Center campus. This is the parking structure for the entire campus. It's a highly logistically challenging parking structure because of the amount of traffic flow in here. This structure is busy 24/7, 365, limited downtime. We removed 150 watt high pressure sodium lamps in here and went to a 2-lamp 32 watt high ballast configuration with a wide distribution reflector. If you notice the alignment of the fixture, it's actually lined perpendicular to the beams within the parking structure, which allows for better cross illumination. Half of the structures were put on a split zone time clock because the ambient light levels within the structure allowed us to go ahead and reduce that quantity of light or the amount of light during the daytime. We're picking up somewhere in the range of about a 60% savings, 65% savings in the parking structure. The parking structure has a payback of less than 1 year, and we've got nothing but rave reviews from everybody from the structure. These lamps and ballasts will probably have zero maintenance for about 5 years. Over behind me here, we actually took out CFL exit signs and went to a 2-watt LED system. And this parking structure is actually set up on the emergency generators for the hospital, so we had to take that into configuration with the wiring and the circuitry as well. Behind me, the elevator landing here is an induction fixture. This will require no service for 20 years. It's on a photocell application, independent photocell application. The reason we went to an independent photocell application was because these were all lit in the daytime unnecessarily. So now each one is lit according to the light levels in that area. If it needs light, it will turn on instantly. There's no warm-up period like there was before with the old HID technology. Now they turn off instantly as well. As you see, if you go down one level where there's more light, the fixture will actually be off. But again, maintenance was a big issue here, and they did not want a fixture they were going to have to service. This will require no servicing for nearly 20 years.
Okay. Hi, I'm Bill Hoover with NovaTech. I want to show you here some work we're doing at the Long Beach Convention Center. Our existing lights down here, if you can pan in, are high pressure sodium. They drop down about 15 inches from the ceiling, which has been a problem for them because some trucks and vans have knocked them off. So constantly replacing them. And if you pan back over this way, you'll see the vapor type fixtures, T8 fixtures that we're putting in here that have a much higher light quality and much lower profile. So we're getting the same light levels with a lot less maintenance problems and a lot better light quality. So that brings out the better colors in the cars. Everybody can see what color car they came in with. And it also assists the security cameras in getting a better picture.